So now before going to the solution here, I have a very quick question to you. When an object is projected from the ground, case 1, body projected from the top of a tower, case 2, under same velocities, 19.6 meter per second, what do you think is the relationship between, or what do you think is the relative difference between case 1 and case 2 in terms of the body achieving the distance, the displacement, time of flight, the corresponding velocities? To be more, just to give you a hint, this is what I expect, in as a solution. Case A, initial height. Case B, initial height. Case A, maximum height reached. Case B, maximum height reached, and why? It's a very humble request that you go through these, the 4 given ratios, the given quantities, and try to compare and contrast what the effects are based on these 2 differences. Okay. Well, of course, there has to be a point that I'm trying to convey here. What would that be? It is because this question is very similar to the one we are about to solve here. And I'm just, extrapolating it to a different set of data so that we prepare ourselves for the coming exams, maybe in 2026 or exams beyond that, later that, right? So, we don't know. We're just trying to give our best here. But yes, once you do this exercise, I'm pretty sure you'll be more confident in dealing with a similar scenario. Okay. Don't worry. You might now be thinking, what if the object is shot down? Yes, that is a very similar question coming up, and we'll do a similar exercise there as well. Okay. Now, coming to the question here. So what we'll do is we'll try to visualize this first. A ball is thrown vertically upwards with a velocity of 19.6 meter per second. Just mention that here is projected up with a velocity of 19.6 meter per second. The ball strikes the ground after 6 seconds. So it is this complete time taken to reach here is 6 seconds. The height from the ground up to which, okay. To understand this better, let us split this complete motion into 2 different individual motions. One is the motion along A to B, which would be like this, motion along A to B, right? And then would be motion along B to C. B to C. There is a transition that happens between A to B and B to C. What is that? Exactly. At B, the ball is momentarily at rest. So velocity was acting like this. It comes to rest, which means at this point the velocity is 0, and then it reverses its direction and it starts coming down. Right? So we'll divide this complete question into 2 different motions, motion along AB and motion along BC. AB acting upwards, BC acting downwards. Now, why are we discussing this? Because the total time of flight is given to us as 6 seconds. What is total time of flight? Is time taken from A to B and then to come from B to C, time taken from B to C. So this time taken 6 seconds is equal to time of AB plus time of BA and then BC, BA and then from A to C. Oh, sorry, AC. Or in other words, 6 seconds is time to reach the top of the tower. Sorry, time to reach the top position from the tower. Time to reach the tower. Wait, this is not a proper way of writing. My bad. Yeah. So maybe time to reach the top position, time to reach the down position, which I mean is the position of launch, and then time to reach AC, which is the ground. Okay. Now, let's see what happens here. For the motion along AB now, please, as usual, what is that? write this along with me. Please write this along with me, right? And then once you have written it down, then replay the solution one more time by not looking at the video, but by looking at your notes. That's what the whole purpose is about, right? Doing the active revision, following the audio through your ears, and the visuals are not the one that I want you to watch it on the solution. The visual should be the one that you have written on your own. Okay, so please write it down once. Yeah. For the motion along AB, initial point is A, final is B, V is equal to U plus AT. What is V? It's the final velocity, which is at B, so VB. What is U? Is initial velocity at A, VA. My bad, this should be VA here. Plus A is minus G into TAB. Time is time taken from A to reach B, TAB. Now, velocity is acting upwards, displacement is acting upwards, acceleration due to gravity is acting downwards, which means acceleration due to gravity will be opposite to sign, or to look in a different way, initial direction of motion is towards north, acceleration due to gravity is acting towards down. It is opposing the initial direction of motion, so acceleration would be negative, acceleration is minus g. So acceleration is minus g, minus 9.8, v is 19.6, vb is 0. Why is it 0? Because it is momentarily at rest at b. So we have TAB is equal to 19.6 by 9.8, which is 2 seconds. Therefore, TAB is equal to 2 seconds. Now this happens for the motion along AB. Okay. Now, for the motion along AB, time to reach B from A is 2 seconds, right? Now we know that if A to B is 2 seconds, B to A will also be equal to 2 seconds. Why? Because time of flight is equal to time of ascent. Time of ascent, the other way around, my bad. Okay, time of ascent is equal to the total time of flight by 2, and is the same as time of descent, or in other words, time of 2 times time of ascent is equal to the total time of flight, right? So time of descent and time of ascent are equal. If time of ascent is 2 seconds, from A to B is 2 seconds, from B to A will also be equal to 2 seconds. So AB plus BC can be written as 2 seconds plus 2 seconds plus AC. Why? A to B, and then, oops, my bad, B to A, okay, A to B, B to A, and then from A to C. So A to B is 2 seconds, B to C can be written as B to A plus A to C, that is time to reach back to the tower, which is 2 seconds, time to reach to the top position from the tower, which is 2 seconds, and plus AC. So 2 plus 2 is 4, 6 minus 4 is 2, therefore, time to cover AC or time to reach C from A is 2 seconds. Okay? So far clear? Now for the motion along BC, where it is momentarily at rest at B, time to reach BA is 2 seconds. Yes, I do understand that there might be a lack of clarity in what I've said before. This would make it more clear. Time to reach AC would be 2 seconds. Time to reach BA plus time to reach AC would be 2 plus 2 is equal to 4 seconds. Now, time to reach BA plus time to reach AC. BA plus AC is the complete time to travel, which is BC. So, time to travel BC is 4 seconds. Okay. Once you have time to travel BC as 4 seconds, for this complete motion, right, for the motion along the path, motion along BC, what is S is equal to UT plus half AT square? What is S? final position minus initial position, which is c minus b. U is initial velocity, velocity at b, time b to c, acceleration is minus g. Is that so? No. Why? Because velocity is now acting downwards. Acceleration due to gravity is acting downwards. Since acceleration is along the direction of motion, acceleration is therefore positive. And since acceleration is due to gravity, acceleration due to gravity will also be equal to positive g. Hope that makes sense. Now, what is VB? VB here is equal to 0. Why is it equal to 0? Because it is momentarily at rest. Therefore, BC is equal to half into 9.8 into 4 square. 4 square is 16, 16 over 2 is 2, is 8, 9.8 times 8 is 8, 8, 64. 64, 698 are 72 plus 6 is 78, 78.4. So BC is equal to 78.4. I don't think I have the proper question here. Well, according to the question, it is 78.4 equal to K by 5. And what is K? K is equal to 78.4 into 5, which is 392.0, which is therefore the value of K is 392. Okay. So this is what we have in this question. Now, if you've done the exercise well, you should be getting something like this. Comparison of the motion between case A and case B, time to reach the peak height, time to fall from peak, and the total time of flight. Similarly, velocity, case A, case B, velocity before hitting the ground, initial velocity, velocity at peak. Both of them will have zero velocity at peak. Why? At the highest point, velocity is zero. Why? Because it is momentarily at rest. Similarly, we have the component for displacement as well. Right? Case A, case B, initial displacement, total distance traveled. Why is the distance not equal to displacement? Why is it negative? Right. So yes, these are the things that I want you to do it on your own, and later come back to the solution, make a note of this. Okay. So velocity, time, then of course height. Okay. Okay. Now we'll go to the question, the one I was talking about, shooting a bullet down from a height.